We will be working on a few examples on Newton's first law in this lecture. To work on problem on Newton's first law, we need to introduce the concept of free body diagram. A free body diagram is a diagram that represents the object and the forces that act on it. We also need to build proper coordinate system. In this example, we have a car, and we have two people pulling on the car, giving it two force that is in the positive x direction, and then there is a friction force which is pointing to the negative x direction, 560 Newton. So we need to add all those forces to find the net force. And remember, when you add forces, you need to add them as a factor. Now, let's give the answer to the example we discussed as promised. The elevator going up problem. The elevator is going up at constant speed. So the elevator is doing constant velocity motion. Constant velocity motion means acceleration is zero, and when acceleration is zero, the net force acting on the elevator has to be zero. And let's do free body diagram. We have tension from cable, we have weight of the elevator. Those are the only two forces acting on the elevator, and since it's constant velocity motion, net force has to be zero, so tension and the weight has to add up to zero. So the answer is B. So you might be wondering, if the net force on the elevator is zero, how can the elevator going up, right? Now remember, force is not the reason of motion. Force is the reason of change of motion. And this is a general strategy to solve Newton's first law problem. So you might be reading the word equilibrium when you encounter a problem like this. Equilibrium means the system, the net force on the system is zero, and the system would be either doing constant velocity motion or at rest. So the net force is zero. Since force is a vector, when we see net force is zero, it means all components of the force is zero. And in 2 dimension, it means x component of the force is zero and the y component of the force is zero. So to solve the problems following our strategy, first we need to identify the main concept. What are we asked to solve? Is it Newton's first law problem? You must read very obvious indication that it's a Newton's first law problem if you read something like equilibrium, at rest, moving at a constant velocity, and then sketch the situation, draw free body diagram, which is extremely important that we are be able to draw free body diagram to solve this problem, this kind of problem. Make sure that you find all the forces, but you are only interested in the forces that are actually acting on the object that you are investigating, not the force from your object to other objects. And then we need to build our proper coordinate system for our problem, and then we just trying to decompose all the forces into components. Sum all the x components, they have to sum up to zero. Some other y components, they have to sum up to zero. Make sure you know how to build your equation, and then it really just become a math problem. You solve the unknown variables, and in the end, we can assess where our solution is making sense. Now let's look at our first example. So this one is relatively simple. We have a mover drags a box with 500 Newton weight across the floor by a rope at an angle of 30 degrees at a constant speed. If the friction, which is resistance, is 163 Newton, what is the tension on the rope? So apparently we need to looking at this box, and the box is doing constant speed motion. So it's a Newton's first law problem. Yeah, so let's draw the free body diagram. What are the forces acting on the box? So as stated by the problem, we have a tension 30 degrees above ground. So we can choose ground level to be X, vertical to be Y. And then we have weight acting on the box. We have friction. We should also have normal force from the ground on the box. So those are the four forces acting on the crate. We want to solve what is the tension. We already know what is friction. So friction is given by 163 Newton in magnitude. So it seems there are two forces has component in the x direction, tension and friction. Normal force and weight doesn't have x component, so it looks like we don't need to worry about those two. So we can at least start Newton's first law problem, right? Because it's constant speed of motion. So the net force on the box has to be 0, which should give us the net force in x direction is 0, net force in y direction is 0. And net force in x direction is the x component of the tension plus the x component of the friction to add up to 0. X component of tension, now this is tension, this is 30 degrees. X component of tension is the adjacent side of this 30 degrees. So Tx should be T cosine 30 degrees. X component of friction is pointing in the negative x direction with magnitude 163 Newton. And solving this, we find the tension should be roughly 188 Newton. Okay, so we solved this first example and the answer looks reasonable to me. Okay, the second example, we have a heavy chandelier with weight 100 Newton, hanged by chain, keyword equilibrium, from the ceiling of a concert hall as shown in the figure below. This angle is 30 degrees, this angle is 60 degrees. Assume the chains doesn't have any mass. What are the tension? Ft1, Ft2, and Ft3. So let's first look at the chandelier. Do a free body diagram of the chandelier. It has weight and it has Ft3, just only two forces acting on the chandelier. So they have to add up to 0. So this is, we're looking at the chandelier first. There are only two forces, right? Ft3 plus weight as vector add up to 0, but they are all in the y direction. So Ft3 and weight is in the negative y direction. And now we know weight is 100 Newton. So Ft3 equals weight equals 100 Newton. Okay. Now we need to look at this joined point, and this joint point, there are three forces acting on it. This one is Ft2. This is my x. This is my y. This is 60 degree. This is my Ft1. 30 degree. Ft3. So we already know, we solved Ft3 equals 100 Newton. And this point is not moving, so this point is at rest. If you sum over all the forces at this point, they have to add up to 0, which also means the net force in x direction equals 0, net force in y direction equals 0, net force in x direction equals 0. In the x direction, we have Ft1 x plus Ft2 x add up to 0, because this force Ft3 doesn't have x component. Now, how to find the x component of T1? We need to find the angle of Ft1. Think about what's the angle of Ft1. The angle of the vector should be measured from the positive x direction going counterclockwise until you get to the vector. So this is 30 degrees, so Ft1, the angle should be 150 degree. So actually it should be cosine 150 degree. This is x component of Ft1. Ft2 is easy, 60 degree. Now plug into the numbers. This actually is negative square root 3 over 2 Ft1. Because cosine 150 degree is negative square root 3 over 2. Cosine 60 degree is 1/2. Now do the same thing for the y direction. Net force add up to 0. In the y direction, all three forces has y component. But as we discussed, what's the angle of Ft1? What's the angle of Ft2? What's the angle of Ft3? Ft1, the angle is 150 degree. And if you want to find the y component, you should use sine 150 degree. Ft2, the angle is 60 degree. Using sine 60 degree. Okay. Ft3, the angle you should go here all the way to here. So that's 0, 90, 180, 270. The angle of Ft3 actually is 270 degree. Plug in the number, this gives us 1/2 Ft1 plus square root 3 Ft2. Sine 270 degree just give us -1. So minus Ft3 equals 0. And this is 100 Newton as we already solved. Ft3 is 100 Newton. So if you combine those two, combine this one and this one, this is 100. replaced by 100 Newton. So you see you have two equations now with two unknown variables. So you just need to be able to solve two equation sets with two variables. Put them together, we can find out Ft1 is 50 Newton, Ft2 is 86 Newton. And this is our answer. Ft3 is 100 Newton, Ft1 is 50 Newton, Ft2 is 86 Newton. I hope this example is helpful for you to understand how to solve Newton's first law problems.